Okay, let's do the second video on 11.8. I'm just going to go through some examples and show you how you find intervals of convergence at different power series. Give you some different examples. Okay, so let's take this first one. This is the summation n equals 1 to infinity x to the n over 2n 2 times n minus 1. Okay, so for different values of n, this thing may converge, it might not converge. So let's see, sorry, different values of x. So I want to see for what values of x this series will converge. And usually use the ratio test. So let's use the ratio test on this. Let's see what an plus 1 over an equals. So that will be x to the n plus 1 over 2 times n plus 1 minus 1. And then I got to divide it by an, so it's going to take this, put it underneath, which is just flip that. So I get 2n minus 1 over x to the n. Now I'm going to clean it up a bit. So this is x to the n times x. So rise x times x to the n. And that's just, didn't do anything with that, I don't think so. 2n minus 1. Then on the bottom, I got this x to the n. I'm going to put that here. So you can see that they'll cancel. Then I'll multiply all this stuff out. So this right here, that'll give me 2n plus 2 minus 1. So 2n plus 2 minus 1. So that's going to be 2n plus 1. Okay, and so this is going to equal, those will cancel, and I'm just going to get x times what? 2n minus 1 over 2n plus 1. Okay, so what's the ratio test do? What is the ratio test? Ratio test, you take the limit as n goes to infinity to the absolute value of an plus 1 over an. And if this thing goes to a number, and if that number is less than 1, then this series is absolutely convergent. If it's equal to 1, the test didn't do any good. If it's bigger than 1, then this thing diverges. Okay, so here's this. So let's look at, so this is going to be the limit as n goes to infinity. I've already cleaned up this. So that's going to be absolute value of x, 2n minus 1 over 2n plus 1. Okay, now you can multiply top and bottom here by 1 over n, and this will give you, this will equal the limit n goes to infinity. When you do that, you get absolute value of x, and that's going to be 2 minus 1 over n over 2 plus 1 over n. That's an n. And absolute values. Now, as n goes to infinity, that guy's going to go to 0, that guy's going to go 0, and I'm just going to end up having 2 over 2, so this whole thing just ends up equaling absolute value of x. Okay, so for the ratio test to work, what it goes to, which happens to be absolute value of x, has to be less than 1. And if it's equal to 1, then I got to do something else that's bigger than 1, doesn't work. So that's going to tell me this guy's going to work. Draw a number line here. When is the absolute value of x less than 1? Well, that's when x is between the 1s. Okay, so I know this thing's going to work from minus 1 to 1. Everything in here is good. I'm not sure at 1 and negative 1, because when I plug in a 1, I get 1. Plug in a negative 1, I get 1. So the ratio test doesn't work. Then the ratio test also tells me if x is bigger than 1, like if it's a negative 7, that's bigger than 1. So anything out here doesn't work. Anything out here doesn't work. I just got to figure out these 2 points now. So the ratio test gave me a whole bunch of stuff. It gave me an infinite number of things here, an infinite number of things here, an infinite number of things here. I just got to test 2 points. So the ratio test just didn't work at 2 points, so don't complain. It did a good job. Now let's go check those 2 points on their own. So the ratio test for this series didn't work at -1 and 1. So let's check what happens at -1. So let's look at a -1. So take a -1, stick it in for x, so the summation n equals 1 to infinity. That's going to be a -1, so I get a -1 to the n power over 2n minus 1. Okay? This is an alternating series. Rewrite it one more time. N equals 1 to infinity, and pull that off a -1 to the n, and I got 1 over 2n minus 1. Now, as n gets bigger, what's going to happen to this guy? This guy's going to get littler and littler and littler. This guy's going to 0, and it's decreasing. So this is a decreasing sequence, and it's alternating. So the sum of this guy is going to converge using the alternating series test. So this guy is good. Now let's check what happens at a +1. Plug a +1, n equals 1 to infinity. Put in a +1, you get it 1 to the n over 2n minus 1. Okay? What do you think is going to happen here? This is going to equal the summation n equals 1 to infinity of 1 over 2n minus 1. What does that look like? That looks like 1 over n, basically. And so I believe this guy is going to not converge. Let's do the limit comparison test with this. Let's do the limit comparison test with 1 over n. Okay, so let's look at the limit. N goes to infinity of 1 over 2n minus 1 divided by 1 over n. What's that going to equal? Flip this, and you're going to get n limit. N goes to infinity, and that's going to give you n on top and 2n minus 1. And that's going to go to the leading coefficients. You can multiply top and bottom by 1 over n, and you'll get 1 over 2. So let's do that. 1 over n, 1 over n. It's going to be the limit. N goes to infinity of 1 over 2 minus 1 over n. That's going to go to 1/2. Okay, so this thing went to a nice number that wasn't 0. It's got to go to numbers not 0. And both series have to be positive terms, as long as we stay away from, let's not 0 if we want, this was, we'll start at 1. Now we're positive. And it went to a number, so this limit converged to a positive number. Therefore, this series and the series that we compared it to, the summation 1 over n, do the same thing. This diverges, so that guy diverges. So that says that this guy right here does not work. Okay, so what are all the places that this series works? Okay, so it works from -1 all the way to 1, but include the -1, don't include the +1. And if somebody wants to know what's the radius of convergence, what's the center of this what is it called? Interval. What's the center of this interval? The center of this interval is 0. And so from 0 out to this side's 1, 0 out that side's 1. So the radius of convergence is 1, centered at 0. But to me, what's a lot more important, what's the interval of convergence? I can plug in a -1, this guy will work. I can plug a positive guy in 1, this won't work. But everything in between will work. So these are all the numbers that work. From -1 works all the way up to +1, but don't include +1. So that's the interval convergence for this series. So this guy, I'm going to write it down here, we had -1 to 1. Let's look at this guy. So we got the summation n equals 1 to infinity x to the n over n factorial. Okay. Now, this may work for certain x's, it may not, so I don't know, so let's see what we would do. Okay, so I see this factorial. On this factorial, what's it going to tell you to do? Ratio test. When we're doing intervals of a convergence, we know they always use the ratio test anyway. So I'm gonna clean up, we're gonna do an plus 1 over an. I'm gonna clean that up. Let's plug it in, clean it up, and then stick it in the ratio test. So that's gonna be x to the n plus 1 over n plus 1 factorial. And then you divide it by this guy, which means I'm gonna put it underneath it, I'm gonna flip it, and you get it n factorial over x to the n. And what's that equal to? That's gonna be x times x to the n times n factorial over, what's n plus 1 factorial? Let me put this out first. That's going to be x to the n. And let's deal with this later. So that's going to be n plus 1 times whatever's left over, which would be n factorial. Should be kind of used to that by now. So what's going to happen? These guys are going to cancel. These guys are going to cancel. And this is going to equal, put over here what we got left. This canceled, that canceled, you're going to just get x over n plus 1, unless I missed something. Okay, so what's the ratio test? It's the limit as n goes to infinity, the absolute value of a n plus 1 over a n. So that's going to be equal to the limit n goes to infinity of the absolute value of this thing we just cleaned up, and that's x over n plus 1. Okay, now you look at that, that's going to be, no matter what you give me for x, give me any number for x. 7,000. As n goes to infinity, I got 7,000 over infinity, that's going to be 0. So no matter what you give me for x, or you could rewrite this guy as absolute value of x times the limit as n goes to infinity of 1 over n plus 1. Don't really need absolute value bars because that's positive. This thing goes to 0. So this is going to equal x times 0. And no matter what x is, that's going to be 0. Okay, what does the ratio test say? If this limit goes to a number, this limit exists, if that number is less than 1, it works. 0 is less than 1 for any x. That means this guy can't screw up. So this guy's radius of convergence is infinity, and its interval of convergence is minus infinity to infinity. This guy always works. So the interval of convergence of this guy is minus infinity to infinity. No matter what x you put in here, this guy will always converge. Okay, that's the kind you want. And we'll be doing a lot of work with this guy in the future. And in DE, when you type me in DE. Okay, let's look at this one. Just like, so is everything I've been doing so far. That always end up being ones and negative ones. They don't have to be that way. Let's look at this one. So you got the summation, n equals 1 to infinity, x to the n plus 1 over n 3n. Okay. Again, I'm going to use the ratio test. So on the ratio test on this guy, so I'm going to look at a n plus 1 over a n. I'm going to clean that up. So that's going to be, where did I get n plus 1? I'm thinking, I'm going to that guy. I didn't have an n plus 1 up here. So x to the n, n, 3 to the n. So this is going to be x to the n plus 1. Must have been doing a ratio test in my head before I even wrote it down. N plus 1, 3 to the n plus 1, and then divided by this guy, so should we flip this guy? So it's going to be times n 3n over x to the n. Let's clean it up. That's going to turn into x times x to the n. This is going to be n 3n. Bottom, this is going to be, I got an x to the n here. Taking care of that guy. That's going to be 3 times 3 to the n. Take care of that one. And then I'm just going to have an n plus 1. Okay, let's look. Forgot something. 1 term, 2 terms, 3 terms. I think I got everything. And if you notice this right here, that turns into a 1. This right here, that turns into a 1. So what's left over? You got x on top, you got an n on top, you got a 3 on bottom, and you got an n plus 1 on bottom. Okay, so an plus 1 over an simplifies down to this. Now let's take, using the ratio test, got to take the limit. N goes to infinity of x to the n over 3 n plus 1 in absolute values, because it's the limit of this guy in absolute values. Okay, when you do that, that gives you, and it's not x to the n, I'll keep writing it, that's x times n. And so this equals, you can pull out the x's because this is, I'm dealing with n, so I got the limit, n goes to infinity of absolute value of x over 3 times n over n plus 1. I can drop the absolute values on that because that's positive. Need absolute values here because I don't know what x is. Could be a negative number. So as n goes infinity, I can multiply top and bottom by 1 over n, but this guy's going to go to 1. So this thing's going to equal absolute value of x over 3. Okay? So this was the ratio test. On the ratio test, you need the limit to be less than 1. Okay? So how do you get, so for this guy to work, I got to make this guy less than 1. How do you get absolute value of x over 3 to be less than 1? That means that x over 3 is going to be less than 1 or bigger than a minus 1. Okay? Let's clean that up and look at it. I want to figure what x is. I don't want to know what x over 3 is. So what is x going to be? Well, let's multiply through by 3. Now, if that was a negative 3, I'd have to flip these guys. So remember your inequalities. So multiply all the way through by 3, so that's going to be a minus 3 is less than x is less than 3. So where does the ratio test tell me that this series works? It works on everything from a minus 3 to 3. I know all the stuff on the inside works. If this is bigger than 1, so on the outside, it doesn't work. The ratio test tells me everything in here works, everything out here don't work, everything out here don't work. One thing I don't know, when I plug in a 3, I get a 1. When I plug in a negative 3, I still get a 1. And the ratio tests don't work at 1, so I still don't know what happens here and here. So we got to work those 2 points out by themselves. So let's plug in a negative 3. So what happens at a negative 3? Plug that in, I get a minus, I get the I get the summation n equals 1 to infinity of a minus 3 to the n over n 3 to the n, which equals summation n equals 1 to infinity. I'm going to write that as a minus 1 to the n times 3 to the n over n 3 to the n. These guys cancel. And so this equals summation n equals 1 to infinity of a minus 1 to the n times 1 over n. That's alternating. These guys decrease to 0. So this is in a convergent series by the alternating series test. So I know that this guy works. That guy's good. How about when I plug in a 3? So when I plug in a 3, what do I get? I get the summation n equals 1 to infinity of 3 to the n over n 3 to the n and that's equal to the sum n equals 1 to infinity of 1 over n. That's a divergent p-series, so this guy does not work. So what's the interval convergence for this thing? It's minus 3 to 3, not including the positive 3. Okay. And it doesn't always work on the left side, not work on the right side. Sometimes they work on both sides. Sometimes they don't work on either side. Sometimes they work on the right side and don't work on the left side. Now, let me give you one. I won't work this one all the way out because it's a little bit complicated to do on this little bit board. It's kind of driving me crazy because it's knocking all over the place. But I just wanted to show you this one real quick. I'll do it on a piece of paper and I'll email it to everybody. So n equals 0 to infinity of n to the n times x to the n. Now if you look at this guy, this is going to grow really, really fast. And to try to make it die, you're going to have x really, really small. So this is going to be a geometric, but this is something that's growing raised to a bigger and bigger power. This is going to grow really fast. It's going to be hard to kill this guy. And what you find out with a lot of work, and do L'Hopital's rule and all kinds of stuff like that, after about half a page of work, you'll find out that this guy never converges. The only way this guy will ever converge is if x is equal to 0. So if x is equal to 0, it wipes everything out and it does converge. But any other number, this guy's going to beat this one and it won't converge. So this guy's radius of convergence is 0 and his interval of convergence is just 0, the 1.0. So the only thing that works here is 0. Its interval of convergence is 0. Its radius of convergence is, its interval of convergence is just the point that contains 0. Its radius of convergence is 0. Okay, and again, I'll prove this one on a piece of paper and email it to you. All right, that's it.